Okay, welcome everybody to today's lesson. This lesson is going to be a brief explanation of the equation of a line. Okay, so graphing is an important skill for both science and math classes, and there's lots of different types of graphs you can look at. We can look at graphs that look like this, look like this, look like this, but today we're going to look at the most basic type of graph, which is the graph of a straight line. Okay, so a graph that gives you a line is called a linear function because it makes a straight line. And what that means by a linear function and a straight line is that it's going to be the same steepness or a straight line the entire time. So it's not going to curve down, not going to curve up, it's going to be the same. And how we describe that continuous steepness is with something called slope. So I'm going to put on a line here. It shows that when we go across 1 unit, we go up 2 units. And that's how steep it is at that point. And if it's a linear function, it should keep that steepness or that slope the whole time. So up here, it goes across 1 and up 2. Even down here, it goes across 1 and up 2. That's one of the major components of a linear function, and it's called the slope. And we describe it just like that, how many units you go across and how many units you go up. So this is called slope, and it's calculated by the rise, the change up and down, by the run, the change side to side. So for this graph, it's a pretty easy calculation. Our rise was going up 2 for our run, which is going across every 1. So we put in for rise 2, and we put in for run 1. And that calculates our slope. We could leave it as 2 over 1 as a fraction if your teacher likes that, or you could just simplify it to 2. Now, taking a look at how that relates our x and y values, as a reminder, the vertical axis is the y, the horizontal axis is the x, that it means if when I go across 1, I go up 2, for every x value, my y value should be doubled. So we see when x is 1, y is equal to 2. When x is equal to 3, y is equal to 6. So whatever our x value, the y value is going to be double. So how to write or describe that slope in equation is just y is equal to 2x. And this is the fundamental starting point of describing the equation of a line. The only other piece that we have to add in is what if I take that same line and move it down a little bit? The slope is still the exact same. I didn't tilt it steeper or more flat, but it's in a place now where if I take the x value and double it, I don't get y. For example, where I have x is equal to 1, the y value is equal to 0. It's crossing the x-axis. So because it doesn't match, I'm not quite done with the equation up here yet. What we have to add in now is say how high or low this is based off where it intersects on y, which is called the y-intercept. So where your line crosses the y-axis. So in this case down here, it's going to cross at -2. So we're going to throw into the equation -2. And how that works is if I throw in an x value of 0, so up here, x is equal to 0. 0 times 2 is 0, minus 2. So it says that if my x value is 0, which is on the vertical y-axis, then my y value should be -2, and I see that's the case. Let's check some other points. If I put x is equal to 1, 1 times 2 is 2, minus 2 is 0, and when x is 1, y is equal to 0. So now that I've just described how much we lowered it by, this is the equation that describes the line, and that's really all there is to it. So the equation that is used to describe a linear function or a straight line is y is equal to mx plus b. I know it looks a little bit more confusing than the last one, but really that m just represents the slope in the last case when we had that as 2. Not sure why they didn't use s, must have been used for some other equation, but m is what we use to represent slope. And then at the end, on the side there has b, and that's going to represent our y-intercept, where it crosses the vertical axis. And that's going to describe any straight line, just those two pieces of information, slope and y-intercept. So let's just take a look at a couple examples if you had to draw these graphs. We have the equation y is equal to 3x plus 1. I would start with the y-intercept, means it intersects at 1 on the y-axis. So I would start with a point there. It means it goes through 1 on the y-axis. And now we're going to use our slope to say, well, 3 is our rise over run. It's the same as 3 over 1. So every time I go across 1, it should go up 3. So I draw going across 1, going up 3, draw my line, and that represents the equation 3x plus 1. This one may look a little bit trickier, but I think it's actually easier because we have a fraction. 3 over 4 is rise over run, so a rise of 3 over a run of 4, and our y-intercept of -3. -3 may seem a little bit more challenging, but it's just like that first example. It means we're down 3 for the y-intercept. So I'm going to start there. And then with my slope, go across 4, go up 3, go across 4, up 3, draw our line, and we get that one. And just one last example, giving a negative slope is really not too much of a change, just means for the rise, the top number here, rise over run, the negative 3 means we're going to go down 3 when we go across. Negative 3 over 2, negative 3 is the rise, 2 is the run. The y-intercept plus 1, so we're going to start there. And when we go across 2, we're just going to go down 3 this time. So it's going to give us a negative slope or pointing downwards. We draw the line, and there's our equation. All right, so I hope that helped you to understand the equation of a line. It's used a lot in math and a lot in science, so I hope you found that useful. Thanks for watching, and I'll see you in the next video.